Hello, and a very warm welcome to another episode of GlobalSBM Business Talk. Today, we are pleased to welcome Mr. Shantanu Kumar as our guest speaker. Mr. Shantanu Kumar is working as data scientist at LinkedIn. Previously, he worked as head of artificial intelligence products at Infido. Mr. Shantanu is an ex-member of Udacity's data team, alumnus of flagship MIT Global Entrepreneurship Bootcamp. He co-created MiMent, a finalist of the program structured around personalized learning plans for Indian university students. Mr. Shantanu is a two-time winner of world's largest annual code competition and an active contributor to Stanford Scholar, with one of his papers voted highest on the platform. A global speaker and guest lecturer at Primer B School, Mr. Shantanu has been a TEDx licensee in past and currently advises multiple early stage AI and EdTech startup. Mr. Shantanu, we are pleased to have you. The stage is all yours.
Thank you so much, Vashu, and very excited to be a part of this talk as well. I think it's as I was saying before as well. I think it's great to be a part of something that you and Kagendra are organizing. I think you've been amazing people across the board and organized some great stuff. So I think very glad to be a small part of it as well. And thanks for the introduction. I will go ahead and share my screen real quick as well. Just give me 1 second.
Yes, I guess you'll be able to do that.
Yeah.
Yes. Yes, we can see your screen.
Oh, yeah. Is it full screen or is it? It's loading.
Yeah, it is full screen.
Okay, got it. Awesome. Yeah. Thank you so much again. And thanks a lot, everyone, for joining as well on a Sunday. Very thankful for everybody to be a part of this. I think largely I want to also give a quick outline of everything that we'll talk about today. Of course, I've spoken about this topic quite a bit over the past few years. I think primarily stemming from the work I did at Infido as well. I think we built some great stuff across the board and thankfully had the chance to go through Y Combinator about 2 years ago. So I think that was validation for us that there was some great work happening while we were doing it as well. So this talk is just mostly something that I've spoken of across the years a bit and tried to learn a little bit about it and tweak it as I've gone through other applications of the same stuff as well. And I think that's where it's mostly drawn from, but very happy to discuss or talk about anything that is conflicting, or if there's anything that somebody here also thinks that it doesn't apply to their use case. I think that's one of the greater discussions we can have across the board as well. The one thing I, of course, as an overview is that the conversation today is mostly about the top things that you want to think about when you're starting an organization that is AI powered, or even just a team or a project within your company that is AI powered. I happened to write a book about it as well with a few people in the industry about a year ago. So I think that's also a place where I had the chance to deep dive in the same topic a little more. But very happy to hear today about any other thoughts that anybody may have. I'm hoping to keep this interactive. Very happy to take pauses across the talk as well. But if not, we'll have some questions at the end, and please feel free to ask or just drop it in the chat anytime you want. So I'll go ahead and begin as well. I think one of the key things the talk speaks about is AI ventures, right? And I think the core part of what forms an AI venture first is artificial intelligence. So I think a very quick overview and understanding of how that works as well is this is a very old data point that a lot of people have used across the board, and this number keeps growing by the day. But artificial intelligence is one of the biggest things that's happened and that's boomed in the past decade, in the past few years. It's been around in many shapes and forms. So I picked up and I started understanding this space when I was about 14, 15. It was called a lot of different things back then, and it changed in meaning to what you would call it. Sometimes it used to be called intelligence from data and so on and so forth. I think it's had a variety of names over the past few years. It's now a very broad gamut of things that are covered in so-called the term artificial intelligence. And it's poised to be one of the greatest contributors to the world economy as we scale as well, because and lots of people have spoken, and lots of smart people have spoken a great deal about how AI is powering our day-to-day as well. So think about everything from the phones that you use, the devices you're currently using, the data that's currently been tracked and used to feed in better decisions, better thought processes, or and a lot of those things across the board back to you. So it's more of a viral loop that's being created, and we're part of it in some way or another. A lot of people, when they start their day, start with something that is either generating data or creating value through data. I think that's where we begin when we start the day. We close off the day by using another device, another recommendation engine, or something of that sort that is feeding into our day to day, whether it's e-commerce websites, a lot of offline players as well these days. I think a lot of the data that we generate, both online and offline, is being used to power our experiences online and offline as well. So I think a few examples, of course, as I mentioned, recommendation engines that we're a part of, e-commerce, shopping experiences, lots of products that were recommended. Everything across the board is looking like the same space. Of course, as I said, the gamut is very broad, but everything that is poised to be intelligent through data is what broadly is referred to as this term as well. I describe AI as a very strong base for industries as well. And right after this is when I'll just take a pause. But how AI is currently structured is a strong foundation to many industries. Like there is, for example, education is one of the biggest use cases for artificial intelligence, how people can build stronger learning outcomes for students. We know that there is a very prominent research that happened a couple of decades ago, sometime called the Bloom 2 Sigma effect in education, which says that students do better by two standard deviations in terms of their performance when they have one-on-one mentors. And I might be quoting the study wrong, but I think one-on-one mentorship, personalized education has shown its value across the decades, across industries. And that's how the entire private tutoring space was also born and continues to thrive, because we know that education needs to be personalized and not standardized by just putting a lot of people in the classroom and just teaching them the same thing the same way. Healthcare is another very big sector where there is great opportunities, and we've seen with the coronavirus as well. I think the slides that I've put in this talk are from before the virus hit, so a lot of that holds even more true as we go beyond and scale as well, because we know that not just drug discovery and just creating better drugs can be powered through artificial intelligence, but also the fact that a lot of recovery and a lot of tracking and testing has also shown that AI can be used in many ways across the board. HR is a vertical that I worked in very deeply at Infido. At Infido, we spent some time building an HR chatbot called Amber. And Amber used to speak to employees at regular intervals, and she still does, to understand whether they were happy, engaged, likely to leave the organization. And that gave us a lot of insights across the board on whether people are about to leave, whether they're unhappy, how are they feeling about things. So that's one of the other domains where we spend almost, some would say half, but if not a little less than half of our living lives working. And HR seems to be one of the places where you can actually optimize for better productivity, better well-being for half of your life. I think that's where it comes from. And of course, then there's lots of tons of different verticals that form a very strong base for industry. And it remains, as I've seen in my experience, that as a platform and as a foundation, AI remains very agnostic to industries. There is a lot of applications that, and when I say AI, I will clarify later in the slides as well what commonly is referred to as AI today in the industry. But whatever that is referred to as, it works across a lot of verticals, and there is something in many verticals that can be powered through AI. I'll just take a quick pause here to see if there's any thoughts, questions anybody has before we move on as well. Awesome. I'll move forward. This is the common. So when I was speaking about common representation of AI, I think one of the key things is that people refer to AI products today as very, very narrow products. And by narrow, I mean that as I was describing each industry and each particular vertical, I think narrow is when, as you see in the diagram as well, everything that we speak about in AI is very for a particular use case built. So something like when you talk about self-driving cars and when you talk about, say, e-commerce recommendations, or even your Facebook feed that you scroll, that all of the content and everything that flows into your feed, a lot of that is built very narrowly in that the data from that use case can only be used within that use case. So if I'm building a e-commerce recommendation platform, my algorithm can only do that. Like it can only predict e-commerce recommendations. It can only do that one thing. And it uses the data that I gave it for particular training in that one time period. And nothing beyond that, nothing before that, nothing after that. And as I like to say, it freezes in time in that the same data that you use, and of course, talking about most use cases in the industry and not all, that they freeze in time. The same data that you used is used to build that model once, and that is the only data it usually has. And people do retrain data sometimes when they refresh the data, train the model again, and say, for example, there is a new artificial intelligence use case that they build out using data, but it always just remains for that one use case and it remains for that one time period. One of the key things we've seen, at least with coronavirus, right, and I'll move into that in some more depth as we go forward with our discussion today, is that a lot of what we freeze in time will not be useful ahead of time. Say, for example, if I built a e-commerce prediction model before 2020 March or before 2019 December, it would have mapped a particular kind of purchase history. It could have mapped a particular kind of e-commerce behavior, of consumer spending behavior. But that completely flipped on its head in 2020. People started either saving money or spending way too much. And that was very unprecedented behavior across the board from us as well. So I think a lot of models could not bake into account what happened as the time switched. So everything really needed a data refresh, everything needed behavior refresh. And that's the problem that happens when models or AI verticals are very narrow, that you're not fully understanding across time what happens, because people change, right? And everybody knows that humans change as they grow up, as they grow old, with new experiences, old experiences. And at the end of it, AI is basically mapping human behavior. So it needs to take in account all of the changes that happen in human lives and how human behavior changes. And that is the data we need to keep refreshing. And that's one of the biggest problems with current AI applications, that they are very narrow and not all of them provide very scalable opportunities across the board. This is another slide I think has historically drawn a lot of questions. So I want to take a quick pause as well. And I'd encourage, of course, that I would love if we interact a little more in terms of the questions, or if you have any thoughts, please feel free to share. But also that we know that a lot of these talks used to happen in person before, and now they are happening over Zoom calls. So if you guys want, please feel free to turn on your videos so that I can see a lot of you, and I'll even call upon some of you then, so it's easier.
Yeah. Just want to know, does AI also talk about data on the future backward?
So by future backward, you mean if I can predict in advance looking at history?
Yeah.
So it's usually that is one of the main.
Generally, as present, we as I have gone through one of the Bento training from US. So it's talk about future backward, but it also talk about don't give referral to the what has happened in the past.
Yeah.
Just think of present and be validate with what will be in the future. So always not backed by the future data, whether it be business or yeah. So just please elaborate.
May I add something? So as from my knowledge, what AI does is they study the behavior, right? If you have some kind of application, they study the historical behavior of that particular product, and they give a future reference that might be accurate, might not be accurate, because it's not that the market is changing day by day, it's expanding a lot. So how much accuracy? I think Ramanji's questions is on that one. How much accuracy does it give to us? The output will be of how much accuracy? Is it 100% accurate, or is it?
No, actually, my question is about does AI also talk about future backward only? Actually.
Okay.
Got it. So I'll take both of these questions, and thanks a lot, Raman and Manish, for asking. So for starters, I think, Raman, from what I understand about your question as well, is we use a lot of data from the past to predict the future. And sorry, go on. Yeah. So I think that's one of the, as Manish also mentioned, that is one of the core applications of how AI is currently used today. We build a lot of historical context into models. We build a lot of what has happened in the future and try to look ahead and try to predict ahead to see whether this is going to happen, whether this is going to scale. So that is one of the most common applications of it today in the market. That is how it's being used mostly. But just to extend to what Manish was also saying when it comes to accuracy, how accurately can we even predict the future, right? So I think one of the things that happens is, and Manish very rightly said that things don't change day by day. Consumer behavior usually changes across time, or it has to have one big event, like something like happened, like coronavirus or something that happened. It has to be a very large event for consumer behavior to really change. Otherwise, it usually changes very, very slowly, very gradually. So when it comes to accuracy, there is a very interesting anecdote that I speak about in my book as well, and also very famously quoted. It's an anecdote by the mathematician Michael Barry. He says that when you speak about predicting the future, if I imagine, everybody must have played pool or billiards of some sort, right? So I think you have a stick, you hit it with some balls, and you have to put it in the pool table in the holes. So he says that when it comes to predicting the future, the first hit of the ball can probably be predicted by some variables, like, if I know how well the player plays, if I know how well are they holding the stick, are they having a good day, what is the temperature, all of that, what is their current mood. These 2-3 things can help me predict how well they will hit their first shot. When it comes to the 5th or the 6th shot in billiards, I will probably have to bake in things like what did they eat for breakfast also sometimes, because that will have some small impact on how they are playing in the future. And these 2-3 things will probably help me predict a little better by the 5th shot. He says by the 13th or the 14th shot, I have to bake in every single atom in the universe to be able to predict how well that person is going to play by the 13th or the 14th shot. And the anecdote basically says that you can't practically bake in all those variables, right? Because he says that the effects of something so small will play a role in how that person is playing pool that day. Is that it's so small, but it is also a very crucial factor. So as you expand the duration of your future, if I want to predict maybe half a day in advance, I might be a little more accurate. But if I want to predict 10 days, 20 days in the future, I will have to bake in so many variables that I will never be able to predict accurately. And our AI models today cannot do that, because computers cannot, every single atom of the universe cannot be baked in computationally today. So if we can probably do that, then we will arrive at a place where accuracy can increase. But till the time we can't do that, a lot of what is happening is that at the end of it, you will have so much data outside of the model that you don't really know whether this is right or wrong anymore. So I think that's the state of accuracy as well. Also, I think I'll move forward from here as well. I hope that answers your question, Raman, Manish.
Yeah, I got that one.
Thanks. Yeah.
Thank you so much.
I'll in fact move forward across the slides as well. Happy to take some questions at the end, because I think the slides will get over soon, and then just save most of it to the end. So the next thing is, I think this is just a description of what I was just talking about, that how AI products are very narrow in nature, because people think of them as very, and this is a very long-standing debate in the artificial intelligence space as well. People think that AI models are very strong today. They are not, and they're not going to take over humanity today, at least. And this is the state of them today. I think they just can identify images, cats, dogs, and I think that's what they've been doing today. But doesn't take away from the fact that they could be somewhere else in the future. One of the key things I speak about every time people are building AI models is that, or even just building products that can be AI powered, is that it usually makes sense to watch a trend before you jump on the AI bandwagon. And what I mean by watch the trend is that if I am building a model that is in an industry that is very volatile, and I'll speak a little more about this as well. If a lot of things about the industry, about the use case are constantly changing, your models will not be able to bake in a lot of account from historical data, because the past is also changing every day. The past is sometimes in some very small domains or pockets. Usually the historical context does not change every day, does not change every week. But there are some domains, like for example, we take healthcare and a lot of these things. Some particular pockets of each domain are very fast moving. And you don't know how people will behave maybe 1 week from now, maybe 2 weeks from now. And a lot of times it is very useful to understand market trends, market behavior before we build data backed historical intelligence into our products. Because every time we do that, one of the key assumptions we make is that our data will be good at explaining the future well, which means my past needs to be more or less similar to the future for us to be able to make an accurate prediction into the future. If my present is changing continuously, it is useful to understand the market externally first before building out data backed intelligence historically. I think that was mostly about a very broad overview of how people are building AI into products. I think the key things and this is also midway through our slides as well. I think one of the things I often speak about is when you're starting out, when you're first thinking about building an AI product, there are three crucial things that you want to keep in mind. I call them the 3Ds: the data, distance, and differentiator. And I'll get into each one of them now. One of the first ones is domain specific data. Every time you are building something in a particular industry, in a particular domain, say, for example, human resources, energy, education, as I've mentioned here as well, I think one of the key things to know is that domain is very specific and very specifically different from other domains, which means, as I was saying before as well, there are some behaviors in some domains that work differently than other domains. Maybe a lot of things are changing every day in energy. Maybe they are not changing that much in education. So always you want to start with data that is very specific and captures the nuances within your domain. Because if you are building something that is intelligently powered by data in your domain, you need very specific nuances from your data. And I'll give you an example. If I'm speaking about, say, education, or if I'm speaking about pool and billiards games like that, I need data that can specifically account for skill inside classrooms. How do I predict whether, if I want to predict whether a student is going to do well tomorrow or day after? I need data about that student's education history. I need data about how well they have been doing, how they are doing, who is teaching them, how are they teaching them, and a lot of that data. Because I cannot take data from one different domain and try to predict something in a different place. And that comes to the same point of narrow products that I was speaking about. You need a lot of domain specific nuances in your data every time you're building it in. Say, I cannot use purchase behavior on Amazon or Google search history to very accurately predict how a person is going to do in their test. I need data very specific to what they are doing. And a lot of times, and why I've put this may sound like very common sense, but why I've put this here is because a lot of people don't think of this directly, because it comes as a shock, but a lot of people use very different data to predict very different things. And that should not always be the case, because you need to cater for the nuances that your domain has. Like, you need to get all of the data from a particular domain and viewpoint that you live in. One of the limitations, as I was discussing with Manish and Raman earlier right now as well, was that the limitation to this is the data, the number of variables you can account for are unlimited practically. Because if you want to predict a very far future ahead into, say, a particular, if I'm standing here today and I want to predict maybe 1 month in advance for something, I also need to keep understanding what is changing, what is happening, and take into account a very, very large number of limitations and very, very large number of variables that I always cannot do, because there are only so many things that I can capture in terms of domain specific data. And there are some things that will never be captured by data. And one of the key limitations that I speak about is also that data is something that is either qualitative or quantitative at the end of it, right? Because data is generated when somebody is generating it, when we are digitally putting impressions of ourselves into the universe. If I'm clicking on my phone, if I'm clicking on my app, or if I am making a purchase online, that is generating data. But there is a very large realm that is currently not generating data. Say, for example, if I had one conversation today with Raman, and Raman and I spoke, there is no data between us right now, because I spoke to Raman, Raman responded back to me. There is no data generated for this yet. So there is still a lot of places in a particular domain and in the world right now that is not digitally connected. And till the time you map that into the ecosystem as well, there will always be limitations from data, because data is everything that is online, and data is everything that is at least digital for us to use right now. And there is a million things maybe in the day that we do that there is no data for. And maybe one day we'll be in a place where there is something of that sort. But currently, maybe as I was saying earlier as well, if I wake up late before an exam, that will also impact how well I do my exam. But there is not always digital record of when I'm sleeping, when I'm waking up, how well I'm waking up. And a lot of this world is not digitally mapped. Until the time we get to a place where a lot of the things are digital, data will always have those limitations, because it's capturing a very small set of things that are happening online and not really offline. The next one I speak about is how far away the user of the product is. And this is, I think, one of the most debated slides I've had historically. But from my research in the book as well, when I recently wrote it, I've expanded this to something we call VUCA environments. VUCA is basically environments that are, I think the full form of it is volatility, uncertainty, and two other things. I don't fully remember off the top what VUCA environments are, but basically, as I was mentioning before, environments that are either often changing or vulnerable, in that it is very sensitive to use data to predict certain things in particular environments. Like, and I'll give an example. If we are building predictive models in healthcare, we need to be very sure about where this prediction is going. If I am predicting like sensitive domains, say, for example, if somebody has a life-threatening disease like cancer, I cannot directly go predict and tell the patient that, okay, this model is saying you have cancer, so you have cancer. Because there is a very sensitive element to a particular domain like healthcare. And there are a lot of other domains like this, where vulnerability can either be human-based or financial-based or anything like that. Because there are also environments where if I predict wrong, the downside is very, very high. If I predict something incorrectly through a machine and it changes somebody's life, and this is very common in the US environments of judicial studies as well, there was a model that people were building to decide whether a person will come out of jail on parole or not. So if we have models like these, we need to be very, very specific. And these models give scores and a lot of that on how well a person is doing in jail, how they are interacting, whether they should be let out or not. And I think a lot of these things will play in a big role in environments like these. And we need to cater for that as well across the board, because environments like these require a very high level of stability. from either a machine making decisions or people making decisions. And that's why there are a lot of review processes, a lot of those things. And it's very commonly known that every time you go to a doctor, right, people go for second opinion, third opinion, and a lot of that on the same if a disease has come up or something has come up. And that's only because we need stronger reliance on one opinion that we try to get it from other people. But if machines come into the play, the environments change a lot. And thanks a lot, Deepak, for the full form. I think the full form is VUCA is volatility, uncertainty, complexity, and ambiguity. So I think a place where it's not clear enough, where it's sensitive, and where things can go wrong, we should be very careful of how our model predictions are used in the real world, because sometimes they can have life-changing damages or life-changing situations for people. And the final one, of course, I think is a very commonly known one across the board is your AI model should at least, and your AI product should have something that is being predicted that is an actual value add to somebody who's using it, which means it should not be something off the book that either somebody else is already doing and somebody else can provide the same kind of input, but it should also be something that is not very replicable in real time already without the model. Say, for example, if I build a model today that tells me what time is a good time to wake up, there can be some good use cases to that model or that product as well. But there is also something that I can probably do without a product like that, because I might have an understanding of my body clock better than that product does. I can understand my routines and a lot of those things better. So it needs to be unique, not just in the fact that unique from a different product or different venture, but also unique from a point that you cannot replicate it yourself easily. And it does not have to be, it has to be something that is a strong value add to the current way you are living or doing something. And I think that also feeds in very accurately to the final slide I have as well. I think every time you're thinking about building a particular product when it comes to intelligence like this, I think one of the key filters that I've used and has often worked out very well for me is that there is something called a 10x filter that I use. Every time you are building a new product, a new use case, it's good to understand how well it would scale before it even gets put out into the market. So you want to make sure that wherever you are starting, is your product going to save somebody's time? Is it going to save somebody's money? Or is it going to reach more users manually from the same thing that people have been doing? So an example would be that, and in the space that we were in with Infido was the HR function. And when you think about HR functions in companies in large organizations, there is one HR to talk to 500 people, 600 people, sometimes even more people in very, very large organizations. What happens there is one person can never have the kind of time to speak to everybody, maybe on one day or 1 week or even 1 month. You can't speak to 600 people without burning your head out or doing something like that. It's a very tough task. And more importantly, if you want to reach 600 people as a company, you will have to employ a lot more HR. And even then, there will be a lot of time spent unnecessarily on things that you don't really want to spend time on. Scheduling, talking to people in different time zones, and a lot of that. So the 10x value filter helped us in that case, in that now if we put an HR bot there, the bot can save a lot of time for the company by getting all 600 people's opinion on one particular minute or one day directly. It saves money because I don't have to hire so many people from the HR domain. And it enables reach in that I will get to be a part of, I will get to touch 600 people directly with just one bot rather than 50, 60 different HR people going, because that is not manually scalable if we go to 6,000 or if we go to 60,000. But a product like that can be used to scale. So I think this is one of the key filters that I've often used before we decide whether something should be put out from an intelligence domain or not. But I think that also brings me to the close of the talk as well. But we're very happy to discuss any particular slides, any questions you may have. And I think we can devote the next 10, 15 minutes to thoughts and questions as well.
Yes, we can definitely